Previously, we discussed stability. We defined what stability means from input-output point of view, and what stability means from initial state point of view. We also discussed how to determine stability of an open loop system by looking at its poles. We saw this example. We saw that we have four systems here. System 1 or T1 is stable because it only has one pole, and that is on the left hand side. System 2 is marginally stable because of this pole on the imaginary axis. System 3 is marginally stable too because we have two poles on the imaginary axis at plus j and negative j. And then plus system 4 is unstable because we have a pole on the right hand side. So then the question was, what happens if we give the system an input, a stable input? Well, the stable system would produce a stable output for a stable input. So our stable system would produce bounded input for the bounded output for the bounded input. My unstable system would produce an unbounded output for a bounded input. But for marginally stable systems, it depends. It depends on that input. If that input has the frequency, which is the natural frequency of the system, then the output would be unbounded. Otherwise, it's going to be bounded. To show that, we designed this setup in Simulink. So I have my stable system is this. My marginally stable systems are these two. So this output and this output. And then the unstable system is this last four. I'm once giving it a step input and then giving it a sinusoid with frequency of 1. Why am I doing this? Well, I want to see what happens to my stable system. If I have a stable system and give it bounded inputs, sinusoid or step, what's happening? Well, if I have a stable system, if I give it bounded input, the outputs should be bounded. So for the step input, the stable system's output is bounded. For the sinusoidal input, the answer of the stable system again is bounded. So bounded input produces bounded output for the stable system. For the unstable system, the response to a step input, which is bounded, would be unbounded. So for the unstable system, the response to a step is unbounded. The response to a sinusoid is unbounded as well. So for an unstable system, doesn't matter what the input is, as long as it is bounded, you're going to have an unbounded output. So that's the unstable system. Now we want to look at the marginally stable systems and see if the input can affect that. Remember, for a marginally stable system, input matters. The frequency of input matters. If the frequency of the input matches the natural frequency of my system, for a bounded input, I'm going to have an unbounded output. But for all other inputs, a bounded input is going to create a bounded output. question. For this system, what's the natural frequency? What is that pole that makes this system marginally stable? Well, it's this pole. So S equals to 0 is that pole. For this system, my poles that are making this system marginally stable are plus minus J. So the frequency of omega equals to 1 is the natural frequency of this system, and the frequency of omega equals to 0 is the natural frequency of this system. So if I give my system, my marginally stable system, an input which has the frequency is a sinusoidal input with the frequency of 1, this system doesn't care. It's a marginally stable system, but its natural frequency is 0 radians per second. So it's not going to really react to a sinusoidal input. But this system does react if I have an input which has the frequency of 1. Because that's the natural frequency of this system, this output is going to go to infinity. So I'm giving a sinusoid with frequency of 1. My marginally stable system with s squared plus 1. In the denominator, that is going to produce an unbounded output. But to the step input, which means it has the frequency of 0, this is the system that is going to behave, that is going to react and produce unbounded output, because the frequency of input is 0 and the frequency of the marginal stable system is 0 too. The natural frequency of it is 0.